Hi guys, hope you're doing well. I've already discussed all these about the electronic configuration and filling of orbitals with the electron by following Aufbau principle in my previous video. Just please watch my previous video, and this is the continuation of that video. So I have already explained the shape of s orbital, p orbital, d orbital, and I taught you, look at that. The atom, we can resemble it as like a big building. Like atom has center part has electron, center part has nucleus, and that all these. So this is the center part. That center part is the nucleus, and we have shells. In that shells we have electrons. Mostly that shells has subshells, and subshells has orbitals, and orbitals contain electrons. So like each shell or energy level, we can resemble it as the floor or the levels. Like a big building has different floors or different levels, like a level 1, level 2, level 3, level 4, level 5. So in each floor you can find flats. So each shell has subshells, and we number as like SP, like SPDF. So level 1, like S shell, S shell has S subshell, S subshell has S orbital, just one S orbital. Then each floor, I said to you, has flats or suites. So S level 1 has only S subshell, S shell has S subshell, S subshell has only one orbital, and that orbital can have maximum 2 electron or minimum 1 electron. Look at that. And second floor, we have second shell, we have P subshell as well as S subshell. So S has only one orbital, and P has 3 orbital, Px, Py, Pz, and each one has 2 electron. Now the third shell has S subshell, P subshell, a D subshell. S has only one S orbital. S subshell has only one orbital, S orbital. P has 3 orbitals, Px, Py, Pz, and a D has 5 orbitals. I drew the shape of the D orbital. So D can have maximum 10 electron. So you can fill 1, 1, 1 first, then the pairing start. Now the fourth shell has S, 1s, 3p, 5d, 1, 2, 3, 4, 5, and with that we have f orbital source. Fourth shell has f orbital, 4f. Yeah. Now look at the shape of the f orbital. Normally the f orbital is very complicated. It has 8 lobes. So we don't need to worry about the shape of f orbital, but we can say f subshell has 7 orbitals, and we can fill minimum 1 electron and a maximum 14 electron. Look at that. Now shape, we don't need to worry about the shape of f orbital, but it has 7 orbitals. F has F has F has 7 orbitals, and we can fill one each, then the pairing star. Now F has 7 orbitals. Look at that one. 1, 2, 3, 4, 5, 6, and 1 more. 7 orbitals. And we can fill one first, one electron. Then the pairing star. Each orbital has maximum 2 electron and a pairing. So we can fill 7 electron in F orbitals. Okay, now look at that. We have to follow Aufbau principle, and he has given some energy pattern from lower to higher. Let's see. Now look at that. Energy levels. Yep. So this is followed by NLX method. N is the main energy level. L is the subshell. Subshell has orbital, and X represent number of electrons. Okay. Look at the energy level, guys. And this type of explanation you can't get it in any textbook. So first 1s, first energy level, O shell or the orbit. 1s can have minimum 1 electron or maximum 2 electron. So this area, this slot completed. So the shell which is close to the nucleus is the S shell, and that is filled. Okay, S shell, and I have already explained you their number as n equals to 1, n1, n2, n3, or k, l, n2, n3, n3, k, l, m, n. They are numbered as k, l, m, n, or n1, n2, n3. Okay, so first shell has one subshell, which is S subshell, and S subshell has only one orbital, and we can fill only 2 electrons. So that's the close to the nucleus, less energy, then followed by 2s. 2s has 2s and 2p. 2s energy is less than 2p. So we can go p up to 6. 2s, sorry, I need some space. So we can start 1s, which is less than 2s, which is less than 2p. Second shell, second energy level, we have S and P. You can go 2s, 1 and 2. 2p, 1, 2, 3, 4, 5, 6. Now, one energy level completely filled. Then we have to move it to second energy level. N equals to 2, which is also completely filled. Then we have to go to third energy level, 3s, which is less than 3p. What is next? Can anyone guess what is next? 3s, then 3p. Now look at that. This energy level also filled up. We have to move to next energy level. So this energy level done. We started with the first one. First energy level has only one subshell as subshell, one S as subshell, one orbital. Second energy level has S subshell and a P subshell. S has one orbital, P has three orbital. So you can fill 2 electron, you can fill 6 electron. Then the third energy level, we move it to third energy level, third orbit. Third energy level has S subshell and a P subshell. S has one orbital, P has three orbitals. Now after that, we can move to 4s. Fourth energy level, we have S subshell. Fourth has, when you go to the fourth energy level, D subshell start. To write the D1, follow like D subshell equals to n minus 1. Sir, I didn't get it. D subshell start when my main energy level it's n minus 1. So D subshell start, D subshell has started. D subshell has started. D subshell or D subshell, we can find D subshell. We can start filling when n equals to 4. When n equals to 4, you can see D subshell. So n equals to 4 means 4 minus 1, D. So the next energy level is 3D. So 4s energy level is less than 3D. D always come into picture when we have fourth energy level. But the D is moving inside. D is always n minus 1. So all the shell are completed. When D comes, D is always n minus 1. D is not the outer shell. D is inner shell. Then we have 4p. This energy level is completed. D started from the fourth shell, but D electrons are not coming into the fourth energy level. D electron goes into the third energy level because the D is hiding in between 4 and 4s and 4p. So D is on the third energy level actually. Now, but the D orbital we can start filling when we move to the fourth energy level. Now, fourth. Now after D, after fourth shell, now the fifth shell, 5s, which is less than 4D. D always, guys, remember that D always n minus 1. 4D, which is less than 5p. Fifth energy level is also completed. Now the sixth one. What next? 6s. There's a slight trick here. When we have sixth shell, so F orbital has to start filling. We have F orbital. F orbital follows like n minus 2. When my main energy level is 6, then F is 4. So no doubt F orbital start from the fourth level, but we can fill only when we move to the sixth energy level. So 6s first, then we have 4f, then we have 5d, then we have 6p. With this energy level, guys, you can write the electronic configuration of any element in the periodic table. We will do some example. So fourth energy level for F. 3D, D start when my main energy level is 4. And F start when my main energy level is 6. When you fill the sixth energy level, then you have to start filling the F orbitals. F orbital is always n minus 2. Like the D block element and F block element, they are always in between P and S. So they are in between, they are hiding. Like we have actinide series, lanthanide series. I will teach you when I will teach d block elements. So just follow this energy level. You can write the electronic configuration of any element in the periodic table. Now we can write the electronic configuration of some elements in the periodic table by following these energy pattern. You can understand better when you do one example. We will do the easy one, like for example zinc 30. Why I have taken zinc 30? Because it has d subshell. Now you want to try it, follow this energy pattern and try the electronic configuration. Write the electronic configuration of zinc 30, mean zinc has 30 electron. How you want to fill the 30 electron in various subshell and various orbital. So we can start 1s2 first. 1s has how many electron? 2. Follow NLX method. Then we have 2s2, 2p6. When you are writing the electronic configuration, don't write this symbol, guys. That's the energy symbol. Okay, so 10 electron completed. Then we have third energy level. 3s2, 3p6, 18 electron. How many remaining? 10 remaining. Then you have to fill the 10 electron. Okay, now 4s2, 20. 4s2, 20 electron. Now 3d10. Okay, yeah. So I told you d is always n minus 1. D equals to n minus 1. When my main energy level is 5, d is 4. When our main energy level is 6, d is 5. Okay, now can we write the electronic configuration of fluorine 9, chlorine 17, chlorine, bromine 35, iodine 35 plus 18, 35 plus 18, 53. Yeah, 53. I will teach you how to write the atomic number of element in the periodic table. So just write the electronic configuration. Bromine 35. After argon is in zero group element. We have helium first. Helium, neon, argon, krypton. Krypton 36. Yeah. So 1s2. Okay. So this is the organ, electronic configuration of the organ. You can write the short form of organ, like organ, like you can write in the bracket AR, meaning the electronic configuration of the organ. What's left? 4s2, 4s2 left, 3d10 left. How many electron? 5 electron left, 4p5. 4s2, 4p5. 7 electron in the outer shell. That's why bromine keep in 17 or 7 group element. Okay. Now when you see the d block element, especially the copper and chromium, there is some exceptions. Those follow anomalous behavior. The electronic configuration is not like how we think. When you are writing, you have to take care. There will be a slight difference. Let's see. Can we write the electronic configuration of chromium first? 1 mark question. Or copper. So write the electronic configuration of chromium first. Chromium 24 and a copper 29. See, chromium 24, copper 29. Electronic configuration of chromium, chromium Cr24, 1s2, even you can write argon 18, but I want to start like this: 1s2, 1s2, 2s2, 2s2, 2p6, 10, 3s2, 3p6, 18, 4s2. So D subshell has 5 orbital. D has 5 orbital. D has 5 orbitals. Look at that. D has 5 orbital. 1, 2, 3, 4, 5. One electron, then one more electron, one more electron, one more electron. This is 20, 21, 22, 23, 24. Okay. 3d4. But this is not the right electronic configuration, because this electronic configuration will not give the stability to the electronic configuration of the chromium. This electronic configuration is incompletely filled electronic configuration. In this electronic configuration, d orbitals have incompletely filled. So what we will do, because of the less energy difference from 3d and 4s, we can jump one of the s orbital electron to d, and we can rewrite the electronic configuration like 4s1 3d5, which is the stablest configuration. And this configuration is called half fill. Half fill. Half fill is more stable than the partially filled. Same we can see, or similar pattern we can see in copper 29. Copper 29, most of the students are writing the electronic configuration like organ. I don't want to write again organ. This is organ 18. Then we have 4s2 3d9. Okay, so good, fine. Like 3 d orbital has how many? D subshell has how many orbital? 5. 1, 2, 3, 4, 5. And one electron first. 1, 2, 3, 4, 5, 6, 7, 8, 9. But when you write this type of this like this electronic configuration, it will not give stability to the copper. This will not lead to the stable configuration for copper. Copper has incompletely filled orbital here. So what we will do, because of the less energy difference from the 4s and 3d, we can jump, or jumping of electron take place at room temperature from S to D, very less energy difference. At room temperature they can jump. So we can write 4s1 3d10. 3d10 configuration is the stablest configuration, because in this configuration d orbital has completely filled. D orbital get 10 electron. So that's completely filled. Completely filled electronic configuration is more stable than the half filled, which is more stable than the partially filled. So can we write the electronic configuration as of S2 minus? Now, sulfur 16. Look at sulfur. Sulfur has 16 electron. When you look 16 electron, so do this like the normal electronic configuration. What does 2 minus mean? 2 minus means sulfur is a non-metal, and non-metal gain electron. It gain 2 extra electron. So 16 plus 2 electron. So it has 18 electron. 1s2, 2s2, 2p6, 3s2, 3p6. This configuration becomes the configuration of organ because it gains 2 extra electron. So write the electronic configuration of aluminum 3 plus. Aluminium, Al, 13. 3 plus meaning it lost 3 electron. Aluminium has 13 electron, it lost 3 electron. Now aluminium has 10 electron now because it lost 3 electron. So how to write the electronic configuration of Al3 plus? 1s2. In that way, you can write the electronic configuration of ions: 1s2, 2s2, 2p6. Okay. So when you will get ions from cation. So ions can be metal, always metals lost electron and non-metal gains the electron. Non-metals, metal got a positive charge and non-metal got a negative charge. Negative charge meaning gain electron, positive charge meaning lost electron. Lost 1, 2, 3, depends on the group. Gain electron. Gain electron, you have to add electron when you are writing the electronic configuration. Lost electron mean you have to take away the electron. We will do some more example in my next video. Guys, I want to wrap it here, and if you have any question regarding the electronic, how to write the electronic configuration of any element in the periodic table, please write your comment in the box and send it to me. I will reply it. Thanks for watching my video. Goodbye.